Good morning. This is Ms. Billerbeck, and we're going to talk about 10.3, analyzing functions graphically. So here, if we have functions that look like this, we can tell pretty quickly what our equations are going to be. We have a parabola that is going downward. So we also see that at this point, we have a y-intercept here at 0, -3. So we could write for this equation, we have f of x equals, and then we have a negative x squared. So we also see that it's not shifting at all. And we see that it's out here at 2, 4, and this is a 1/2. So we're going to be actually shifting it a bit. So we have a bit of a flattening going on. So our A, if we look at here, we have a rise of 1 here, or -1, and a run of 2. So we're going to have a -1/2, and then we have x squared. So since we have a vertex here at -3, we're going to be dropping it down. So we can approximate it to something like that. So -1/2 x squared, and then -3. So the parent graph is being flattened, and it's being moved down -3. This one we see, oh, okay, we have a 1-to-1. So 1, 1, it's going to be negative. So this one we'd have a g of x equals a negative, and it's an absolute value function, and it's dropping also -3. All right, this one here, we see, okay, this is an exponential function. So let's call it h of x. We see that it's reflecting down. So we're going to have a negative value. And let's see, we're at -4 here when we're starting. So if we look at an exponential, we have a b of x, and then we have a -h plus k. So we see that normally this is your k. So we have at -3 an asymptote. So this is an asymptote. So then it does look like, since this is a 1-to-1, that this a is a 1. See how we move 1-to-1? So that's a 1. And then we have a negative reflection. So probably we have a negative in front of this b. And the b looks like, let's see what's going on. So if this was at -4 here, -4 would mean that this is at a 0. So the h would be 0. So let's see, what would that be? So we'd have, oh, it'd just be x. Okay, so we have x for our exponent without an h, because there's no shifting going on. And then let's say it's 2. So let's try 2 for our b and see if that works. So if I have at 1, 2 to the -1 is still 2, I should be at -5, and that works. So that's how you would figure out, from looking at the graph, an equation. So when we look at the domain and range of these equations, this domain, I'm going to abbreviate as D, and we can use parentheses and brackets to make it quick. So our domain here is, it's going to go off to -infinity. So we can write a -infinity like this, and it's going to go off to +infinity. So we can write like that. The range for this, well, it's stopping at -3, but it's going down to -infinity. So we always do parentheses for infinity, because we never quite reach it, but we are reaching -3 So we're going to put a square bracket. So this is another way to write domain and range. Okay, this domain and range, let's see if it's any different. So this domain, it's going off to negative and positive infinity as well. It's also the range, so it's negative and positive infinity. The range is going to negative infinity, but it is also stopped at -3. So it has the same domain and range as this. So let's take a look at this one. So as far as our domain, it's going to negative infinity this way. It is slowly going to negative infinity this way. All right. So we again have that same domain, but the range is different. So let's take a look at that. So our domain for this would be negative infinity, infinity. Now the range is different because it never quite reaches -3, though it is going to negative infinity on the y-axis. So we have -3, and then we'll have -3 with a parentheses. Okay, so let me write that a little more neatly so you can really see that parentheses. So we have negative infinity, infinity, but with the range, we have negative infinity, comma -3, and we have a parentheses, not a bracket, because it never ever hits -3. That's what an asymptote is. All right. So we are going to be analyzing these graphical functions a little bit more in depth now that we're more comfortable with them. So we want to sketch and describe our domain and range, of course, and also our extrema. So the extrema are the maximum or minima, maxima or minimum, so minima. So those are the plural forms of maximum and minimum. And extrema is plural of extremum. Okay, so let's take a look at, well, what is this one here? So we see we have a y-intercept right here. So we can plot that. When we put in 1, so we have 1 squared minus 3, so that's -2, plus 1 gives us a -1. When we put in 2 here, we have 2 squared, which is 4, minus 3 times 2 is 6, is -2, plus 1 is also 1. Whoops, but that's on 2. So 2 is right here. So we see something is happening right between here, but we know that this point's going to be right there at 3. So let's double check it. So 3 squared is 9, minus 3 times 3 is 9, so that's 0, plus 1 is there. So we know we have an axis of symmetry, and we can do a really quick sketch, maybe put one more number in there. Well, we have an axis of symmetry going on right here. So to find the extremum of this graph, we would need to find what is it at 1 1/2. So let's quickly calculate. So we have 1.5 squared minus 3 times 1.5 plus 1. So 1.5 squared, that's 15 times 15, is 225. So that's 2.25 when we put in the 2 decimal places to move over. And this one is 15, 4.5 plus 1. So when we subtract 4.5 from 2.5, we can just do it this way and make it negative. Okay, and so that's going to be 0 to 2, and it'll be negative. So this is about at 1, and we're going to add the 1. So our answer will be -1.2, which is right there. So that would be the minimum. So this has a minimum at negative 1.2, and that's at 1.5. So that would be its minimum. Okay, so then our domain, it's going to infinity in both directions. So we can write negative infinity and positive infinity like that. And then the range would be restricted at the negative 1.2, but it would make it at 1.2 and then it goes off to infinity. So if we were to graph this, it would look something like this. Okay. All right, so we don't need this anymore. So let's take that off. So now let's look at this one. So this one, we see that it has a bit of a shift going on. So we see it's +1. So when we do the HK, it's always X minus H. So that means this is minus -1. So that means we're going to shift it over here. So to get this at 0, we'd have to put in -1 right here. So -1 + 1, 0, 2 times 0 is 0. So we start here because we can't have anything less than 0 in the square root. So then we try 0 next, and square root of 1. 0 + 1 is 1, so the square root of 1 is 1 times 2 is 2. So we're up here. Our next square root is 3 or 4. So if we put in x is 3, we get this 3 + 1 is 4. So the square root of 4 is 2. 2 times 2 is 4. So we're up here. The next square root is 9. So we're going to choose 8. So right here, 8 + 1 is 9. The square root of 9 is 3. 2 times 3 is 6. So we're going to go right there. So we can graph this one like this. Okay, so when we describe our minimum, so this is a minimum point. So the minimum for this one is at, and that's going to be x is -1, 0. And the domain then will be, we're going to have a bracket here though, because it is at -1. And then it's going off to infinity. So we use parenthesis. The range is going to be at 0. And it actually is 0. So we're going to, again, use a bracket at 0. And then this also is going up to infinity. So we're going to write infinity like that. All right, let's take a look at this lovely cube root. So we see with the HK format, we've shifted 1 and then we're up 5. 1, 2, 3, 4, 5. So we should have an inflection point right there. So let's check it out. So this is, oops, sorry, that's the wrong one. So 1, 5 right here. All right. Because that's a -1, we would use 1. Okay, so don't be confused. This is correct for our positive h is x -1, so that'd be a +1, whereas this is x minus -1 for that shift to be into this -1. All right, so let's try 1. 1 minus 1, 0. 8 times 0 is 0. The cube root of 0 is 0 plus 5 is 5. So that gives us our inflection point. So it's not a maximum, it's not a minimum, it's an inflection. So an inflection point, and that would be at 1, 5, because we don't have much going on. We don't have a lot of restrictions with our cube roots. Okay, so next we want the cube root of 8 because that's 2. So if we make this a 2, 2 minus 1 is 1, 8 times 1 is 8. So that'd be the cube root of 8 is 2, 2 plus 5 is 7. So we would plot this. Okay, again, if we make that as 0, 8 times, x minus -1 is -1. 8 times -1 is -8. The cube root of -8 is -2. -2 plus 5 is 3. So we'd have point here. All right, our next cube root would be 3 times 3 times 3, which is 27. Okay, so we would want to get 27. That's going to be tough with this 8 here. So let's just make a sketch because it doesn't ask us to do the full thing. So we know to get down to one more, we're going to be doing something similar to this, where it's coming through, it's inflecting like this, and then back out that direction. Okay, so that would be our cube root with the inflection point right here at 1, 5. Okay, so our domain then for this would be -infinity to infinity, and our range would be -infinity to infinity. And again, with infinities, we never use a square bracket, we only use the parentheses. So that's what we're looking for with describing the extrema, okay, which are, this is an extrema right here, and that's an extrema right here. And this one really doesn't have an extreme, but it only has an inflection point. But that's an interesting thing about a cube root, is the inflection. All right, let's go on to the next one. So this particular one, we have sketch and identify the axis of symmetry. So if we sketch this one, g of x, so when x is 0, 2 to the 0 is 1. When x is 1, that gives 2 to the 1 is 2. When x is 2, 2 squared is 4. When x is 3, 2 to the cubed is 8. When x is -1, that's just 1/2. 2 to the -1 is 1/2. 2 to the -2 is 1/4. So we have something like this that's coming up slowly, curving up like this, and then going up like that. So that's this function. This one does not have an axis of symmetry. So we can't identify an axis of symmetry for that. Now this one we can see from here that this is really, let me use a different color here. This one is the cube root of x minus -4. So we're going to put our point right here at -4. So you can't quite see that -4 because that's how we get that plus. Okay, so we're at -4 here for an inflection point because that's 0. -4 plus 4 is 0. Then our next point would be, we want the square root of, let's go with, we want the square root of 1. So if we have -3, -3 plus 4 is 1. So the square root of, oh, this is cube root. Well, the cube root of 1 is 1. So that gives us this point here. And we also have the cube root of -1. if that's a negative 5 plus 4, would also be negative 1. Okay, so now we want to get to 8. So 4 plus 4 is 8, which is a cube root of 8 is 2. And then we want negative 4, so we're going to go to negative 8 here. Negative 8 plus 4 is, wait, that's not right. So 4, oh, we want negative 12 plus 4, which is right here, which gives us negative 8, which is right there. Okay, so now let's draw that. Okay, so when we look at that, we see we have an inflection going on here. If we did, let's look at lines of symmetry. So if we had something like that for a line of symmetry right there, it's not quite symmetrical. If we folded this over, it wouldn't fold over perfectly. Okay, so it's not going to have a line of symmetry for a cube root either. All right, so we can't identify an axis of symmetry for that. But now let's look at this one here. So this is x minus 6, which gives us a shift here. So when x is 0, the absolute value, when x is 6, 6 minus 6 is 0. So we have a vertex right here. And then when it's 7, it's 1. And then when it's 5, it's negative 1, but it's the absolute value. So we're going to look like this and have a nice little absolute value v. Okay, this does have an axis of symmetry right here. And it is the only one of these that has an axis of symmetry. This axis of symmetry is at x equals 6. All right, and so that's the only one we have, and that would be the j of x. It's the only one with an axis of symmetry. All right, let's take a look at the next problem. All right, this wants us to compare the end behaviors of the functions. So let's just do some brief sketches. So this particular one, we have the x minus negative 2, that makes that a plus. So if we look at y and x, we see, okay, that's shifting it to negative 2 right here. Okay, and at negative 2, that gives us negative 2 plus 2 is 0. So 2 to the 0 is 1. So we just have a little shift of the exponential. So it's going like this. Okay. So this end behavior, it does have an asymptote right here, still at y equals 0. So let's write y equals 0 is my asymptote. Okay, so it's not going to go beyond that. So we have the domain going forever to negative infinity and forever this direction as well, but very slowly. But the range is what is affected. So the range, it can't quite get to 0, but it goes to positive infinity. So that's the only thing that's really restricted is the range on this. So let's sketch this one. So this one, we've got a shift up of 4. But this is 1/3. So 1/3 is a little tricky. So when we have 0, that's at 1. So 1/3 to the 0 is still 1. So 1 plus 4 is at 5. 1, 2, 3, 4, 5. So we have a point right there. Now, as soon as we hit -1, that flips this fraction over. So we have 3 plus 4. So if this is at 5, our next point would be right here. All right, we have an asymptote at 4 because that's what that is. This is an asymptote. So our asymptote is at y equals 4. And so we could graph this particular one to look like this, where it approaches like that. All right, so this one, again, our domain and range are going to infinity on both sides, but the range here, we're coming in from infinity and we're getting restricted at 4, but it can never be 4, so we have a parentheses. All right, this particular one, let's look at our end behavior here. So this one, we see, oh, that's a perfect square trinomial. That's actually x minus 1 squared. So that means it's shifted over to 1. And it's going to look something like this when we graph it. So this one does not have an asymptote, but it has a minimum. And that minimum is at x is 1, 0. It does have the same situation with the domain going to negative infinity and positive infinity, but it's restricted here with a range as well. So this range does hit 0. So we're going to use a square bracket, and it is going to positive infinity. So we'll use a parentheses. So that are the end behaviors of all these different graphs. All right, so that's it for this section. Have a wonderful day. Bye-bye.